We're going to start off by talking about aggregate functions in SQL, or just how to call SQL functions from inside of our queries directly. We're going to learn what they are, why they're useful. Then we're going to talk about foreign keys, along with these things called joins, and how to use them in both raw SQL and in Next. And then we're going to put it all together in a project. Sound good? So let's start off by talking about using functions in SQL. Go ahead and open up Table Plus. And let's create a new connection to the Northwind database file. Same one we've been messing around with in the previous projects. So we're going to create a new connection. We're going to choose SQLite as the connection type. We're going to click Create. We're going to click Select File and go to the northwind.db3 file that's in the data folder of the project. Northwind.db3, open, and we're going to name it ODB3 Northwind. And then click Connect. Julio, you can use whichever you'd like. You can use SQLite Studio. There's another one called SQLite Browser. Whichever one you like best. I like Table Plus the best because it's a lot cleaner. It runs a little better. Once you get this open, open up the order detail table. You'll see that in the order detail table, we have a quantity for each product in the order. So each row is an order, and each order has a quantity. Or each row is a product in an order, excuse me, and each one of those products has a quantity. So let's say we wanted to write some SQL that allowed us to see the total number of times a product had been ordered in total, including the quantity of each order. So let's open up the SQL tab and let's just start something like that. Let's write a query that just says select wildcard from order detail. Let's say we wanted to see how many times the product with the ID of 11 was ordered. So we can have a where the product ID is equal to 11. Go ahead and submit that. That's a good place to start. And you'll see that we get over 8,000 rows as a result. We have over 8,000 orders for this specific product ID of 11. And each one of those orders has a different quantity, right? So if we wanted to see how many times this product was ordered in total, including the quantity, it's not only 8,000, but then we have to go through and add up each one of those quantities, right, to get that total number. You with me so far? It would take forever to do that. That would be really tedious to go add up all those quantities manually. So SQL, it actually has special functions that we can call right in our query to do these sort of calculations before it returns the result. So for this example, if we wanted to see the total quantity for this product, we could come into our query. And instead of selecting a wildcard, let's select sum and then call sum as a function. And we're going to pass the column name of quantity and submit that. And you can now see that the product with the ID of 11, it's been ordered about 206,000 times. And it gives us the result of that calculation just right here in this temporary column, right? It just has the name of the selector. If we wanted to give that a better name, we could use an alias So if we go to the selector and we say as total, and that'll give us the result in a column with the name of total. So in this case, sum, it's just a special type of SQL command that's just a function, right? It's similar to a JavaScript function where it takes some input parameters and it returns a value. So we are able to perform a calculation from within the database engine itself, which is way faster than trying to do it on the JavaScript side of things, right? Let's say we wanted to see the number of times every product was ordered rather than this specific product of 11. What if we just removed that where command? You'll see in that case, we get the total number of products ordered overall in the entire database, which is, it's hard to read without commas, which is about 15 million, almost 16 million. But that's not what we want. We want the total for each product individually. We want to see how many times each individual product has been ordered without checking them each individually. So there's another command we can use for this to group together with our aggregate function sum called group by. Say group by, and let's group by the product ID. And then also select the product ID along with that sum. So we're selecting product ID and the sum of the quantity from the order detail table, and we're grouping that result by product ID and see what that gives you. This is essentially saying perform this calculation for each product ID and return each row as its own row, each result as its own row. Now this query is probably going to take a while to execute. It might take anywhere from 1 to 5 seconds on your computer, since it's doing a ton of math under the hood. Okay, if you look at if you looked at the order detail table, you'll see that it has about 621,000 rows. And when we run this query, it's going through each one of those rows and it's totaling the quantities for each product. All right, that's actually pretty impressive. That's a pretty impressive time considering how much work SQL is doing under the hood. In my case, it took about 1.6 seconds. So what do you think the advantage is of running these functions in SQL rather than doing it just in the JavaScript code? Why is it better to run these functions on the SQL side in the engine itself? Yeah, so we don't have to deal with sorting algorithms. SQL can do it a lot quicker, less callbacks back and forth over the network. It's more efficient. Exactly. It's much more performant to do it this way inside the database engine itself. This way, we don't have to pass as much data back and forth, right? For example, in this case, if we were to run this calculation in the JavaScript, we'd have to return 621,883 rows over the network to our application into the memory, perform the calculation, and then potentially even send that result back to the database, right? That would be extremely slow, especially if the data needs to move over a network, right, over the internet. You wouldn't want to return 621,000 rows in a single API call. That would be crazy. So it's much better in this case to perform the calculation on the SQL side, which we're able to do with these functions. So keep that in mind. This is another Just another SQL skill to add to your tool belt. Keep this in mind when you need to perform any type of calculation with the data from your database. Keep in mind that you might potentially be able to do it right in the engine itself, right in the database engine itself, without having to pass that to JavaScript and run the calculation in JavaScript. So that was sum. That just adds together the values from each row. There's a whole bunch of different functions that we can use in SQLite. If we take a look at this page, a whole bunch of different functions that do different things. The functions themselves, remember that they're dependent on the DBMS that we're using. So these are the functions that are available for SQLite specifically. But if you're using PostgreSQL or MySQL, some of those other DBMSs, they might have additional functions that do different things. But these are all the functions that we have available to SQLite. If you click on some of these links up here, you can see some of the date and time functions, which help with dealing with dates and times, obviously. Aggregate functions, which is what we just used. We used the sum function, but you can also use min or max or total, count, average. A lot of cool things we can do here. Any questions so far? All right, let's see if you can figure out, I'll give you about 5 minutes. Let's see if you can figure out in a single query how many products are in each category. So we have the category table. Nope, I don't want to buy it yet, later. I have to order it. I'll open it in a new tab. So we have this categories table. We have a list of 8 categories, right? And if you look at the products table, okay, that's gonna bug me. I better just buy it. The products table, we have a category ID. Okay. Let's see if you can figure out, using an aggregate function, how many products are in each category. I'll give you about 5 minutes, and then we'll go through it. Once you get the query, go ahead and post it in the thread. Don't peek at it if you haven't given it a try. You might have to jump over to the SQLite docs and see how that count aggregate function works. So don't be afraid to jump into the docs if you need to. All right, I'll give you about 1 more minute. All right, go ahead and stop where you're at. So Josh, the answer would be different for each category, right? So you'd essentially have eight different answers. Cool, let's go through this. So in a single query, figure out how many products are in each category. We're going to use the category ID column in the product table with the count aggregate function. So we're going to be selecting from product. So we're going to select something from product. That's a good place to start. What are we selecting? Well, we're going to select the category ID for one thing, because we want to know which category has which categories belongs to which count. And then if you look at the documentation for the aggregate functions and the count function, you see you call count, and you can either pass a wildcard or a column name. So the count x function returns a count of the number of times that x is not null in a group. The count wildcard function with no arguments returns the total number of rows in the group. So we just have to call count in our selector, just call count. And you can either pass a wildcard, or you can actually just not pass anything and it'll do the same thing. So we're going to call count. And let's give that an alias, so we don't just see some strange column name in our result. Let's give it an alias of total products. When we're defining aliases, you can either define them with as, right after the identifier, as alias, or you can just pass it right directly after the identifier. Either way works. The as is optional. All right, so we're selecting category ID and we're calling the count function. We're giving count an alias of total products from the product table. If you were to just run that as is, you're going to see 77 for category 1, but that's not what we want. We actually want to see the result for every category, not just one. So we're going to say group by category ID. And there we go. We can now see for category 1, we have 12 products, category 2, 12, 3, 13, so on and so forth. So Jose, Kirsten, Mark, when you called count, looks like some of you put a wildcard, some of you put a column name, say like product name. That's going to work just as well. In this case, we don't really have to specify a column name. You can just call count. And that's functions in SQL. Pretty simple, but they give us a lot of power, a lot of flexibility to perform all kinds of different calculations in our database engine. Any questions about that before we move on? Good one, Randall. Let's see, someone asked a question. I think I've seen whole websites stored onto a database. Is that possible? I mean, including the code of the web pages itself. Yeah, you can always store source code. If you just view the source in your browser, you'll see a bunch of HTML. You just store that in a text column, right? Or a blob column. Nothing stopping you from doing that. All right, well, let's go ahead and switch gears. That was kind of the first half of the lecture, using these functions. Next, we're going to talk about relationships. Remember that the type of database that we've been working with is a relational database. So defining and using these relationships between different tables is kind of one of the main features of using a relational database. Before we get into that, remind me, what is a primary key? Who remembers what a primary key is? What is a primary key when we're talking about our database schemas? It identifies the row, a unique identifier in a table, non-null, unique value, good. The identifier for a record, good. So a primary key is essentially the identifying column or columns. It can actually be multiple columns, which we'll talk about later. But it's the identifying columns of a table which should be unique for each row, right? No two rows should ever have the same primary key. Now, this is the first step in understanding how relationships can be defined in our tables, how tables can relate to each other. So we've got each table has a primary key, right? Each row has a unique primary key. We also have these things called foreign keys. A foreign key is a type of column that points to the primary key in another table. It points to the primary key of a specific row in another table. It's essentially creating a link between multiple tables. Okay, so for example, if you have a blog database with many different authors and blog posts, right? So you'd have an authors table, right? How would you associate a blog post with a specific author? Maybe your first thought would be to do something like this. I hope it's not, but it might be. I've seen databases like this in the past. Maybe you would create an authors table and then you'd create a column for each post, something like post 1 text, post 2 text, post 3, post 4, post 5. But this approach has problems, obviously. Mainly, it just wouldn't be very scalable, right? Since you'd be essentially limiting the number of posts that an author could have by the number of columns that you had. So this is no good. Instead, we'd want the posts to be in their own table, right? So you'd split that up into two tables. You'd have an authors table, a posts table. But then you'd also need a way to associate each blog post with the author. You still need a way to associate a post with an author. So maybe you'd create a third column, call it author ID. An author ID just contains a value, an ID that points to an author. This column right here, this author ID, that's the foreign key. Okay, that's the foreign key. It contains values that point to the ID primary key of the authors table. So with this setup, we can now create as many posts as we want for an author without being constrained by the columns. And all we need to do to associate an author to a post is create a foreign key column with the same data type and the same data type as the primary key. And then you just store a value that's the same value as the primary key it points to. Right? You just create a new row and you put in the primary key of whatever author you want to associate with a post. And that's how we create these relationships between tables. Do you think that foreign keys, do they need to be unique like a primary key does? Do foreign keys need to be unique? Nope, they do not. Obviously right here, you see we have two authors ID of 2. Right, the job of a foreign key is to actually point to another identifier in a different table. It's pointing to an identifier rather than being the identifier. So you can have multiple foreign keys in a table that point to the same primary key, as long as that primary key is unique. Right, as long as there's not 2 authors with the ID of 2, you can point to that author multiple times. Right, many posts can point to one author. Good, Randall. So that's foreign keys. That's how we define these relationships between tables. Let's jump back to Table Plus and open up the product table. Where is this table using foreign keys? Supplier ID, that's a foreign key. Right, supplier ID, it points to the ID column of the supplier table. Right, it's pointing to this column right here. Category ID is also a foreign key, pointing to the ID column of the category table, right? So we've got 2 foreign keys here, 2 columns that are pointing to the primary keys of other tables. Now we actually, when we're dealing with multiple tables and we're dealing with these relationships between tables, we kind of need a way to query both of those tables at the same time in one go, right? To instruct SQL to read through the foreign key to the other table so that we can see data from both sides in a single request. If we were to just query this, or let's say that let's query the order detail table actually. Let's query the order detail table, say select wildcard from order detail, and let's limit it to 1 result for now. If we were to do that, you'll see that order detail, it also has a foreign key of product ID that points to the ID of a product, right? We see that the product ID for this first order is 11, but that's not very helpful. It's not very, we don't know what 11 is exactly. We know that it's an ID, it's some product, but we don't know what the product is. Right, so if we were to just look at this as with our current knowledge, we'd probably have to make 2 queries from our front end. One query that queries the order detail table, and another query that comes back and figures out what product ID of 11 is, right? What the product name is, what the price is, that sort of thing. It would actually be nice to just see that all at once, right? To see the product name alongside the order, to get it all in one go. So to help us query these multiple tables all in one go, SQL comes with a command called join. So if we were to come into our query, and before the limit, after from, if we say join, and let's join the product or the table of product. So we're saying bring in this other table into this query and include it with the result. So we're going to join product, and then we have to give it some kind of condition. SQL needs to know how to match up the rows from the product table to the rows of the order detail table. So for our condition, let's just say on order detail dot product ID, where that is equal to the product dot ID. So what we're saying here, we're just saying merge the order detail and the product tables, merge them into one temporary table, line up all the rows by using this on condition, and then run a query against that merged table. Right? Consider that temporary merged table a single table. So go ahead and run that query once you get that all typed out. And you can now see the product columns right here alongside the order detail columns. And you can see that the product name of product ID of 11 is actually Queso Cabrales. So in a single query, we got results from two tables using a join. Try taking out the limit. So we just select wildcard from order detail, join product. That query might take a little bit of time to run because again, we're dealing with 621,000 orders. But if you take out the limit, you'll notice that it finds a matching product for each and every order row. So it's just taking the results from each of these tables and then placing them side by side using that on command to determine which rows match up. Yep, we're just adding in the data, Ryan. Nothing's getting amended, nothing's getting changed. This is just adding data to our result. Yeah, it might take a bit to run. It took about 5.6 seconds on mine. But again, that's actually pretty impressive considering that it's going through all of these different rows. If you wanted to make it a little quicker, maybe you could change your query to something like limit 100 or something like that. That'll be a little quicker. It'll respond. Just give it a minute. You can even just leave the limit 1. So that's how we can query into multiple tables in one go using a join. If you notice in the result, we now have a lot more columns in our result since we're dealing with columns from 2 different tables now, right? And you might even notice that some of the columns are duplicated, right? Since product table and order detail table, they both have a column named ID. Our result now has 2 columns with called ID, which probably isn't great. Okay, I'll give everyone a couple seconds to restart your table plus if it crashes. If you need to just force quit and then come back into it and add a limit 1, go ahead and feel free to do that. If you combine all the tables, do you need to repair your computer? Yeah, you got to take it into the shop. Like, yeah, I ran a join on all of the tables in my database. The guy would be like, say no more. I know what happened. Here's a new computer. That's funny. All right, so you notice that we have some duplicate columns. We have a lot of columns here in our result. Let's change our selector to be just a little bit more specific so we don't have duplicate columns or all of these different columns that we don't necessarily need to see. So in our selector, instead of selecting the wildcard, let's select some specific columns. Only this time, since we're dealing with multiple tables, we're joining in multiple tables to this query. We can't just select column names. We have to prefix them with table names, with which table we're selecting the column from. So let's first of all, let's select the ID column from the order detail table by just saying order detail dot ID. And let's select the quantity column from the order detail table by just saying order detail dot quantity. And let's also select the product name column from the product table by just saying product dot product name. Oh, don't forget your quotes. Quotes don't go around the period. There we go. So our selectors are now table name dot column name instead of just column name. So we were able to just query two different tables. We joined in the product table into a temporary table, and then we queried that temporary table, which contains rows from both tables matched up based on the on condition, queries both of those tables, and it returns a result. So we were able to piece together this result based on that data coming from two different tables. And our front end, our client, it doesn't really know the difference. It just gets this result and it uses it. It doesn't really know where it comes from. It doesn't know that that's coming from multiple tables, that it's being pieced together. Right, so our database doesn't necessarily have to reflect our endpoints because we can piece together, we can structure these queries however we want, and we can change the structure of our result. Okay, so Charlene, when we're joining a table, we're just bringing in another table into our query. We're matching up the rows to the main table based on this on condition. And then we're querying that resulting table, which is just a merged table of those two tables that we're querying. Hi, Jeff. All right, the quotes are not absolutely necessary. Question from Slido. Remember, quotes are not absolutely necessary. You can leave them out. It's going to work just the same. But if you want to play it safe, just in case one of your table names or one of your column names is the same as a SQL command, like let's say you had a column name that was join or a table name that was from or something like that, then you're going to get an error, right? In that case, you need to use quotes. So if you just want to play it safe, you can use quotes all the time. Or if you want to live life on the edge, take a little risk, then you don't have to use quotes. All right, this statement's looking a little messy. It's starting to get kind of long with all these selectors, all these table names. Let's clean it up a little bit. We can actually use those aliases that we touched on earlier. Not only can we use aliases with to rename columns, but we can also use them to shorten identifiers in the query itself, kind of like giving table names a nickname. So what we're going to do is right after saying from order detail, let's say as O. And that's kind of like giving the order detail table, it's kind of like giving it a nickname from within the query itself. So now anywhere else in the query that we're referencing order detail, we can now just say O. So O.id, O.quantity, O.product ID. That shortens it up considerably. And we can actually do the same thing with the join table. So right after join product, right before on, we can say as P. And then anywhere else in the query that we're referencing product, we can now just say P. And it should work just the same. All right, let's take a 5-minute break. I'll see you when you come back. All right, come on back. That's kind of cool. How's everyone feeling? I have had no luck getting my videos feeds up on the screen. I don't know what's going on. I feel like I'm just talking to myself without seeing all of your faces. Everybody good so far? All right, so good question in Slido. If we query something and combine two tables in, which of our joined tables will only display, or which our joined table will only display user ID? We created a new category in our base table with the name of user ID. Whoever asked that question, you need to use punctuation. So I think what you're asking is if we're joining in a table that has the same column name as the main table. So if the two tables have the same column name or a column with the same name, which one is going to show in the result? Now the answer to that is both of them. They'll both show in the result the same column name unless we use a selector. If we specifically select columns, we can select whichever column we want. As long as we prefix the selector with the table name, that determines which table the column comes from. So in this case, for example, product table and order detail table, they both have an ID column, but we're only selecting the ID from order detail by prefixing the order detail table name, or the alias in this case, which is just O. Okay, I think that answers your question. It's up to you which one you choose. That's actually, honestly, that's what it feels like, Eric. If no one's talking in Slack and I can't see your video feeds, I just honestly feel like I'm talking to myself. It's a little weird at times. I guess it comes with the territory of being an online instructor. Yeah. All right, let's take the next 3 minutes and see if in a single query, see if you can find the employee's first name and last name associated with order 16608. All right, in a single query, see if you can find the employee's first and last name associated with order 16608. When you get the name, post it into the thread. Oh, was that a Bob Ross emoji? I'm gonna use that. Gotta love the Bob. Yeah, I like to turn off, I don't know why, I just turn off profile pictures in Slack so it just looks a lot cleaner. Everyone gets a color assigned to their name. No, colors are persistent too. It doesn't reset, so when I see your name and it's like a different color, it throws me off. Charlene's green, Sarah's blue, Fish is like kind of a lime green, Jeff is red, Julio's purple, Lindsay's gold. This is how I know you, by your colors. Simone, you're like a kind of a purplish pink magenta. All right, focus on the task. I'll give you about 3 minutes from now. See if you can figure it out. Challenge is pinned, so scroll up. You can't miss it. I'll give you about 1 more minute. If you can figure it out, go ahead and post it in the thread. Just the name. I'll give you a couple more minutes since we don't have any answers yet. It's going to be pretty much the same structure as this query. You're just going to be changing some of the identifiers here. So we have an employee table, which is what you're actually going to select from the order table, and then you're going to join in the employee table. All right, let's do it. Looks like Mark got a query in there. Looks good, Mark. Only in this case, you would be missing the where statement because we're selecting a specific order, right? So I'm going to go ahead and clear that out. First thing we're going to do is we're going to select Well, actually, let's look at the tables that we're querying. So we're going to query the employee table, which has first name and last name columns. Okay, we've got a couple others filtering in here. Good. We're going to be querying the first name and the last name columns from employee. And we're going to go through order, which has an ID column. So actually, let's just select a wildcard from order just to start off, where the ID is equal to 16608. So that's the order that we're dealing with. You'll see that the employee ID is 9. So let's join in the employee table based on that employee ID by saying join employee on, and the condition for this is going to be where the employee ID column is equal to employee.id. And don't forget your table prefixes. I forgot them. So on order.employee.id or .employee ID is equal to employee.id. And with our where statement, we want to say where the order ID is equal to 16608. Submit that. You'll see we still have a ton of columns here in our result. So let's filter it down a little bit so we can see just exactly what we want. Real quick, let's give our tables aliases. So the order table, give it an alias of O. Employee table, give it an alias of E. Make the changes to reflect those aliases. And now for our selector, instead of selecting a wildcard, instead of just selecting everything, let's select the employee first name specifically and the employee last name. And there we go. We see the employee that's associated with order 16608 is Ann Dodsworth. So if you got Ann Dodsworth, good job. Let's say we also wanted to see the customer's name for this order, which if you look at order, there's also another column called customer ID. So let's join that in as well. If we want to add in another table to our result, we can actually have multiple joins in a single query. We're not limited to just one. We can say join employee, but then after that, we can also say join customer. And let's bring in the customer table. Add C, give it an alias of C. The on condition in this case is where the order.customer ID is equal to the customer.id. If you submit that, you're not going to see any changes in your result because we have to select something from the customer table. So let's also select the C.contact name, which is the customer name. Which you'll see is Hannah Moos. So we can query multiple tables, more than 2. We can query as many as we want just by adding joins for each table we want to bring in. If we were to just look at this result without having any context, without seeing the query, what would be confusing about it? How could we make this result better? If you just looked at this without seeing the query, yeah, we don't know what's what. We don't know which person is associated with what, right? Is Ann Dodsworth the customer or the employee? Is Hannah Moos the employee or the customer, right? We don't really know. So once again, let's add some aliases to clear that up. Start to split this up onto multiple lines. Let's give the contact name an alias of customer name. Remember the as is optional. And let's use another operator just so you can get some more exposure to SQL. Let's actually combine first name and last name into a single result, into a single column, instead of selecting them separately. To do that, we can actually use the double pipe or the OR operator, as you're familiar with. Let's to concat different strings. So we can say OR, but it's not actually OR in SQL. It's actually concat in SQL. And concat the first name and the last name with a space, and then give that an alias of employee name. Now that result looks a lot better. Now it's completely clear who is who, and we only have 2 columns to deal with. How neat is that? I gotta go watch those videos again. The nature walk. That should be mandatory material for this class. We reference it enough. Yes, Steve. So if the syntax is actually pretty simple, so we're just selecting the contact name column from the customer table. We're giving it an alias of customer name, right? That gives us this column. And our second selector is actually a concatenation of 2 different columns. So this OR operator in SQL is kind of the same as plus in JavaScript. It's kind of doing this, only that doesn't work in SQL. In SQL, it's actually double pipes. So that's just saying select the first name and the last name columns from the employee table, combine them with a space, and put it in a resulting column called employee name. You can see that this is just further validation that we can do a lot of stuff in our SQL versus doing it on the JavaScript side. You know, SQL is very powerful in terms of organizing our data, structuring our data, performing calculations, a lot of different things. All right, let's say that later down the road, let's say that this employee, Ann Dodsworth, let's say that she gets fired. Ann Dodsworth gets fired, so the company comes into their database, go into their employee tables, and they delete Ann Dodsworth. So go ahead and delete that. Just right click it, click delete. And then hit Command S or Control S to save, or click this commit button here at the top, commit your changes. And she's gone from the database. She got fired. What do you think is going to happen with our query, with our result, now that there isn't actually a match for that particular foreign key? And Dodsworth no longer exists. Well, if you submit it, you see we don't get anything. Blank result, 0 rows returned. Not even the order data gets returned, which actually still does exist, unlike the employee. Same with the customer data. The customer data still exists. But since there wasn't a matching row for all of the joins, nothing gets returned. Why is that? It's actually because there's different types of joins in SQL. the default being an inner join. So by default, we're using something called an inner join. And an inner join, the rules of an inner join say that if there aren't matches on both sides of the join, meaning if both the order and the matching employee don't exist, or the matching customer doesn't exist, then nothing gets returned at all. It's all or nothing. So join types, they really come down to which side of the join is allowed to be empty. Okay, so these are some of the different types of joins we have. Now, when I say sides, usually the left side of the join, or table A, is the main table that you're querying. And the right side of the join, or table B, is the tables that you're joining in. So when we're determining the type of join that we want to use, we're thinking about which side of the join is allowed to be empty, is allowed to be null. So according to this diagram, inner join, the default join that we are using, only returns a result when both sides have a result. When both sides of the join have something, neither side is allowed to be null. So if the first table has a foreign key pointing to 11 in the second table, and the second table doesn't have any rows with a primary key of 11, then that side of the join would be considered empty or null, and it wouldn't return anything. Now we've also got a left join, which returns all rows in table A, even if the joining table, or table B, doesn't have any matching rows for the join. It'll just have a null value for all of those empty columns. Let's change our join to a left join and see if it makes a difference. So if we come here and let's change our inner join for employee, change that to a left join. You'll see in that case, we actually get a result again. Let's select another column just so we can see something from the order table. Let's select order ID, just as order ID. And you'll see with a left join, we get data from the order table, which is table A. We're getting data from the customer table still, which is one of table B. But since the employee no longer exists and Dodsworth was fired, we still get a result, but that column is just going to be null, just going to be empty. And that's allowed because this is a left join and not an inner join. All right, so inner join means that neither side can be missing, only return the results where the two tables actually intersect. Left join means that only the right side can be missing. Right join is the opposite, it's flipped, meaning only the left side can be missing. Full join allows either side to be missing. And there's a few other types of joins out there, but they're really uncommon, so we're not going to talk about them. Let me give you a link to read in your own time. Yes, there is a reason to not always just default to a full join, Justin, because full joins are not very performant. Okay, the left joins or inner joins are always going to be way more performant than a full join. So you only want to use a full join unless you have a specific, or you only want to use a full join if you have a specific reason. So here's a link to read this on your own time, just bookmark it. It'll help you further understand join types and how they work. It'll give you some examples. This is where I got the diagrams from. Keep in mind that this might seem kind of confusing with all these different types of joins. SQLite actually doesn't even support right joins or full joins. If you want those, you're going to have to get into Postgres or some other DBMS. SQLite really only supports inner joins and left joins, and I think outer join. But that's okay, because most of the time, 99% of the time, you're really only going to need to use either an inner join or a left join. Needing a different type of join is pretty rare. So although there are a lot of different ones, these are really the only two you're going to have to worry about. Inner join and a left join. So when you're writing a join, just think about which side is allowed to be empty. If the joining table, if table B is allowed to be empty, if it's okay if it has empty rows, like in this case, then you're going to use a left join. If that's not okay, if you don't want to return anything if that employee doesn't exist, then you're going to use an inner join. Question on Slido. So a left join can be null on the joined table or the main table. So in the case of left join, only table B can be null, which is the joined table, which is employee and customer in this case. Only those can be null with a left join. With an inner join, neither side can be null. With a right join, then the main table that you're querying is actually allowed to be null, which is kind of weird, right? In this case, order, the results from order wouldn't be allowed to be null, but you'd still be joining in some of these other tables. That's kind of a weird situation, which is why that type of join is really rare, because there's never really any case when you're okay having your main table empty, right? You don't want that result to be empty. That's kind of the main piece of data you're querying. Another question on Slido. Sorry if I missed this, but an inner join is the same as a default join. Like default join will always be an inner join. Yes. Inner join is the default. So if you don't specify a type, just like that, that's going to default to an inner join, meaning neither side of the join is allowed to be empty. All right, I know that's confusing. Think about it for a second, let it soak in. It really just comes down to joins comes down to bringing other tables into our query, querying more than one table at a time. And then join types is determining what to do if that joined table doesn't have a result, if that side is empty, if that employee got fired, right? Any questions about that? Any other questions? Yeah, it's kind of like the SQL version of an import. Sure, it's a good way to think about it, Vish. Any other questions about that? I see your question inside of Vish. I'll get to that later on, just so you're aware. All right, well, let's move on to learning how to write these joins in next from the JavaScript code. So we know how to write them in raw SQL. Let's translate that knowledge over to JavaScript. So jump into the project, start the server, open Insomnia. get it all set up, get situated. This project is actually just a simple API for a blog. So it has users, and each user can have a list of posts. Just like we saw in our example here. Only instead of authors, we're dealing with users. So go ahead and get the server started up. Let's make a GET request to get users. On port 4000. Yep, 4000. Make a GET request to /users. Make sure it's returning a list of 3 users. Also, if you want to open up Table Plus again, you can actually close this database for now, Northwind, and let's open up that other file in the folder called blog.db3. So create a new connection, SQLite, select the file, and instead of Northwind, we're going to select blog.db3. Open that up and click connect. You'll see we have 2 tables. We have users, which is that list of users you just saw. And we have posts, which has an ID, some contents, and then a foreign key pointing to a user. And then some other tables that Next uses for migrations and so on. Let's jump into the user's router. And let's create a new endpoint for listing out the posts of a user. So we've got endpoints for listing the users, getting a specific user, creating a user, updating a specific user, and deleting a specific user. Let's create an endpoint for listing out a user's posts. All the way to the bottom of user router, we're going to call router.get. And what should the endpoint be for this? What should the path be for listing out some posts? Should it just be /posts? Good, not just /posts. Since we want to list posts for a specific user, not all of the posts, the endpoint is going to be users/id/posts. Good. Let's also validate the user ID since we already have the middleware available there. Get your async callback function in there. Your try catch statement. And what's the query we need to call for getting a list of posts for a user? We're going to say const posts equals await. What's the DB call? Okay, so we're going to select from posts, the post table. Select all the posts. What else? Since we're selecting posts for a specific user. Good. We need a where clause. So we're going to say where. You can either say where ID, first parameter, second parameter, request.params.id, or you can pass an object. Actually, it's not ID, it's user ID, excuse me. User underscore ID. Do that, or you can pass an object, and you can say where the user ID is equal to the request.params.id. Same thing, it's up to you. Usually I find it's easier to just pass 2 parameters versus an object if we're only dealing with one item. But if you have multiple wheres, then an object can be useful. And that should be it. We can just send that back with res.json posts. Save your file and try calling it. We make another request, call it get user posts. And we're going to call /users/some ID 1/posts. And you should see a list of only user ID 1's posts. If you're seeing posts from other users, that means you forgot to include the where. Let's try calling it with a different ID, maybe 2. You'll see we get 2's posts. Good. Same with 3. So you'll see we get an ID for each post, some contents, and a user ID. Now that user ID, if you were to just pass this information to the front end, display it on your React app, that user ID is not terribly useful to the client, to the user, right? It might be better for them to see the username instead. So let's add a join statement that gets the username based on that ID. Going to come to your query. Before the where, let's add an inner join. And let's join in the table of users. Let's give users an alias of u. And then the second and third parameters are the left and the right side of that on condition. So we're just going to say where the user ID is equal to posts.userid. And then you can also give posts an alias if you want, as p. And then make sure you prefix the selector, the where statement with p.userid. Just so SQLite knows where that column is coming from, if that's coming from users or if that's coming from posts. It's coming from posts. So make sure you specify that. And then what else do we need in this query? What's the last thing we need? If you were to just save this and look at Insomnia, you'll see we still get user ID, but now we get the username. We don't really want the user ID anymore. So let's just specify a selector and let's select specific columns. Let's say .select, and let's select the PID, post ID, post contents, and let's select the users.username. Save that, make your request in Insomnia once again, and we get this nice response with the ID, post contents, and the username. This data is coming from multiple tables. It's being pieced together from our SQL statement, returned as a single result, all because we used joins. Pretty neat. So I've gotten 2 questions about this. Kimberly and also Vish asked in the training kit. So Vish's question, in the training kit, fields in the select statement are encompassed with quotes, including periods. Is there a danger to this? Should we always leave the periods out of the quotes? And then Kimberly asked, does the period go inside the quotes now? So there's a little bit of difference here. In this case, this is just JavaScript, right? This isn't SQL. This is just JavaScript. And in this case, we can actually include the quotes or include the period in the quotes, and it's going to work just fine, since this is just a string. If you were to try to do it the same way as we did it in our SQL and our JavaScript by keeping the period out of the quotes, that's going to give you a syntax error because that's not valid JavaScript. So in our JavaScript, in next, the period goes inside of the quotes. But when we're writing raw SQL, I lost that statement. Let me see if I can get it back. In our raw SQL, sometimes putting the period inside of the quotes works. Sometimes it doesn't. It depends on the DBMS. It's better to play it safe and to just leave the period outside of the quotes. So if we weren't using aliases and we said like order, oh, that's weird. Well, bottom line, period goes outside of the quotes in SQL just to play it safe. And then in JavaScript, the period goes inside of the quotes. I know that's confusing. That's just the way it is. We're talking about 2 different languages here, so they have different syntaxes. All right, let's take another break. Step away for 5 minutes. I'll see you when you come back. Okay, come on back. How are we feeling about everything? I know we have a lot of new content tonight, a lot of new concepts, so be patient with yourself if you're overwhelmed. Let it sink in. I remember I struggled with joins quite a bit when I was first learning them. It took a long time to finally get the concept down as to what the difference was between all the different ones. Really, the entire point of joins is to prevent yourself from having to make multiple queries. That's it. Okay, if we didn't have joins, we would just have to query the database multiple times in a single endpoint. But joins prevent us from doing that, since we can just get everything we need in a single query. Cool. If you need some context on the neatness stuff, go watch that video in that in Blake's thread. If you need some neat in your life, some nature. Did someone just make that emoji? That neat emoji? Was that there before? It's great. All right, well, the last thing we're going to do, so we have this join statement. This is a good looking query. It's pretty straightforward, but there's chances that this query might be reused in other endpoints later down the line. Maybe you have another endpoint that needs to get this list of data. You wouldn't want to rewrite this. I mean, it's only 4 lines, but it is kind of complicated. So we want to make this as reusable as possible. Right? It's not usually great practice to muck up our routers with a ton of different database access code or a ton of different code that does a bunch of things. We should try to extract it when possible. Extract it into its own file. In this case, we can extract this call, this database query, into its own model file. So let's go ahead and do that. We're going to create a new file called user-model.js. And inside of user model, let's create a function and call it find posts by user ID. And that should take in the user ID as a parameter. And then you can just take this query from the endpoint, cut it out of the endpoint, and paste it into this function. And then we actually don't have to make this function async, and we don't have to call await. Instead, let's just return it, just like that. Who knows why we can do that? Why don't we have to make this function async or call await or anything like that? Why can we just return this promise from the function? Yep, exactly, Blake. Just returning the promise directly in this case. There's no code that comes after this promise, so there's no real need to call await. We're not awaiting on anything. We're just returning it. You'll see this pattern a lot. If you have a function that does one thing, it just returns a promise, then you don't have to await it, or you don't have to use a promise chain. You can just return it. And then inside of our router, when we actually use it, that's when we're going to call await. All right, so we extracted that function. Let's make sure we export it. We're going to say module.exports, and let's export an object that has find posts by user ID. And make sure you import the database variable, because we're calling DB. We're calling the next instance, but we're not importing it yet. So let's go ahead and import that just by saying const DB equals require /data/config. And then jump back into the user router. We're going to import this file all the way to the top. So maybe right after DB, right before the middleware, we can say const user model equals require /user model. So import it. And then in our endpoint, last but not least, we can call that new function that we just declared. So we can say const posts equals await user model dot find posts by user ID. And we're going to pass request.params.id as a parameter. So now that query, that's totally reusable. We can now import this function wherever we want, and we can call it in any endpoint. And we don't have to rewrite all of that join stuff. We don't have to rewrite anything. Go ahead and save that and test it out. So we're going to make a new endpoint. Actually, no, we don't need a new endpoint. It's the same one. My mistake. Oh, we get a 500. Something went wrong. Let's figure out where we went wrong. Rec is not defined. Request is not defined in the user model line 6. Ah, we forgot to switch that over to the parameter. So line 6, instead of request.params.id, we want to use that parameter from the function, which is just user ID. Let's try that again. Boom, there we go. Beautiful. Any questions about that? What we just did? We wrote a query that queries the post table. It joins in the users table, finds all of the posts for a user, and then we extracted that query into a reusable function. And that's it. So question from Slido, why do we need to pass user ID as a parameter? Well, the query depends on user ID, right? The query itself, it requires a value for user ID. So the only way to get it from an extracted function is to pass it through as a parameter. So we define it as user ID as a parameter, use the parameter, and then when we call it, you have to call it with the actual ID. Any other questions? That's it for tonight. Where does user ID come from? Well, it's defined as a parameter. This is just a function, right? The function is defined as a parameter. Or the function is defined, the function takes in a parameter, we're using the parameter. And when we call it, that value comes from params.id, which is coming from the URL, right? Nothing fancy going on. This is just a function. You should be familiar with how functions work. Any other questions? Should we just spend the rest of the time watching nature videos? No, I'm saying nature, neat, nature. Nature is neat. All right, well, I'll let you go early. I see Jeff is typing. If you have a question, Jeff. Okay, so for some reason he's getting find posts by user ID not defined on user model. So make sure you're exporting an object, not the function itself. Make sure you're exporting an object. And then when you import user model, you just import it normally. And when you call it, you call user model dot find post by user ID. So a lot of times you just export a function directly, like you just say something like that. And that would also work, but then you wouldn't be able to export anything else from this file. So to make this more flexible, we're exporting an object that contains that function. I'll post all this code up so you can compare. I know that joins can be a lot to take in, especially when we're talking about all the different types and the different sides, which sides can be null, so on and so forth. One thing I will ask you to do just in your own time is find a piece of paper and something to write with and just draw out all the different joins. See if you can visualize it in your own way. And that actually helps a lot to physically draw and map out concepts. Okay, whether it's on a piece of paper or a whiteboard or something like that, it's going to help you a lot. We're actually going to do that a little bit on Wednesday. So if you find some time between now and then, see if you can just draw out joins, draw out the diagrams, draw out the tables, just see if you can visualize it. And yeah, good luck with the project. Have fun with it. Let me know if you have any questions, and I'll see you on Wednesday. Good night.